In this question, we are given y equal fx. The function here is 2x minus 1 into radical 3x minus 2 minus 2, and some points that are non-exact values have been given, correct to 5 decimal places, belonging to this curve. Find the value of k. Given your answer, give your answer correct to 5 decimal places. So k here is the y of b. So I'm going to use the x of b to find the value of k, which means f of 2.0001 is equal to k. Replace the x's in the function by 2.0001, and then you got 2 times 2.0001 minus 1 into radical 3 times 2.0001 minus 2 minus 2. If you do this on the calculator, you will get approximately 4.00063, correct to 5 decimal places. This is 1 mark question. Only correct answers are acceptable. In part B, we're given a table of the corresponding chords AB, AC, AD, and AF. We're missing AE. And he's asking us to find the gradient of the chord AE. Give your answer correct to 4 decimal places. This is 1 mark. For the point A coordinates, we know that A is 2, 4 from the previous given. And the point E, which is 2.1 and 4.63566. And we know that the gradient formula is y2 minus y1 over x2 minus x1. So if we substitute the corresponding x1, y1, x2, y2, we will get 4.63566 minus the x of a, which is, sorry, the y of a, which is 4, over the x of e, which is 2.1, minus the x of a, which is 2. Calculating this, you will get 6.3566, correct to 4 decimal places. Deduce the value of f prime of 2 using the values in the table. As you see, the closest point to A is B, and the gradient of AB was approximately 6.25. So here the answer is 6.25. It's only 1 mark. You can pick up this from the table. Question number 5. Prove the identity sine square x minus cosine x minus 1 over 1 plus cosine x, that it's going to be equal to minus cosine x. Here we have 3 marks. The first mark you will get by substituting or using the formula sine square x plus cosine square x is equal to 1. Making sine square x the subject, you'll get sine square x equal 1 minus cosine square x. Replacing this in sine squared x, you got 1 minus cosine square x minus, copy paste, minus cosine x minus 1 all over 1 plus cosine x. If you simplify this, you will notice 1 and negative 1 will cancel, and the negative will take out negative cosine x as a common factor from the two terms here. So we get cosine x plus 1 over, because addition is commutative, this is equal also to cosine x plus 1, which means we can cancel cosine x plus 1 here, and the answer will be equal to minus cosine x. So you'll take another mark for taking a common factor in this step here, and for simplifying the final answer, you get the third mark. Part B, solve the equation sine squared x minus cosine x minus 1 over 2 plus 2 cosine x is equal to quarter. Notice this is the same expression as in part A, but we have a 2 common factor down, which is equal to sine squared x minus cosine x minus 1 over 2 common factor into 1 plus cosine x. This is equal to quarter. If you substitute this by f of x, this is the same as minus cosine x as we proved it before, over 2 is equal to quarter. If you multiply by negative 2, this will be cosine x is equal to negative half. We have cosine x negative in quadrants 3 and 2. So quadrant 2 and quadrant 3. But first we have to pass by quadrant 1. For quadrant 1, the cosine negative or inverse of half, which is equal to 60 degree. So the basic angle is 60 degree. For quadrant 2 answer solution, we get 180 minus 60 degree, which is equivalent to 120 degree. This is the first solution. And for quadrant number 3, solution is 180 plus 60, which is 240 degree. So we got this work. Question number 6, we are given the graph of an inverse of a function, and we're asked to graph or sketch the graph of f inverse. The function here is 2 over x squared plus 4, which is a positive function. As you see, all the function falls above the x-axis. And to draw the inverse or to sketch the inverse graph, we have to look for symmetry. We should actually here draw the y equal x first bisector line of symmetry here. This is y equal to x. Now we need to draw some symmetry. This will be actually here. This point close to y will be close to x here from down. And here we go. The graph will look like this. I should get a little bit more away from the y-axis, as here the distance the same. Try to make the same distance. So here, that's it more accurately. And here we go. This is our f inverse graph. Here we got 2 marks showing any irrelevant mirror line. In part B, we have to find the expression of f inverse x. So let's go back to f of x. F of x was 2 over x squared plus 4. First, I'm gonna switch x and y. So this will be x equal to 2 over y squared plus 4. And you can keep this step for the end. And try to make y the subject here. So I'm gonna isolate the y. I'll take 4 to the other side. We get x minus 4 equal 2 over y squared. Do cross multiplication here. This will be a y squared equal 2 over x minus 4. So we swap this with y squared here. And to undo the square, if you remember, our graph was for the inverse under the x-axis, which is negative. So doing the square root, it's only y equal negative square root of 2 over x minus 4. That's it. In part C, solve the equation of x equal 4.5. This is equivalent to say that the f inverse of 4.5 is equal to x. So all what we have to do here is to substitute x by 4.5 in the f inverse expression we got in the previous part B. So f minus 1 of 4.5 is equal to negative radical 2 over 4.5 minus 4, which is equal to negative 2. This is 1 mark. Part D, explain why the functions or the equation f minus 1 of x is equal to f of x has no solution. That's because simply f minus 1 is always negative. So this one is always negative, and this one is always positive. If you remember, this is negative root 2 over 4x minus 4, and fx was positive. It was equivalent to 2 over x squared plus 4, which is impossible. Impossible, as f inverse is always negative, while f is always positive. So that's it for today. For more videos, don't forget to like and subscribe. Thank you.